Hello, yo, what's up, guys? Welcome back in another live stream, and now we will start the journey towards learning uh, with better experiences and and here I am Amol on EduMac. Okay, so let's start with some questions and with the complete basics of computers and computer science related all these things and coding. Okay, so many people doubt themselves that why do we start coding or like programming. So that's it because see, okay, so to create and build anything on computers like softwares or any kind of thing, a game, an app, or a robot or machines, so you need to learn coding and programming to automate some boring task like if you create your own startup or a product, so you need to have some coding or programming language. Whether you can hire people, but still you need to have some technical knowledge, so that they may don't fool you. And to build your own versions of ChatGPT or a game like Minecraft, so you can do it, but with very high language, but with very high knowledge of programming. Okay, so actually programming gives you some superpowers in this digital world. So and let in career, in terms of career and its high demand, the tech industry is like booming still now. Software developers are highly paid. Okay, but reason is that right now if you have skills you can be hired very quickly with very high payouts. Okay, you can work remotely, you can do freelance, or you can start your own thing or own startup or businesses. Jobs like exist in every industries like finance, health, space, entertainment, AI, robotics, etc. And each and every single MNCs or companies have a very high level or a very strong IT departments. See whether it may be any kind of industries or any kind of a company in any kind of like uh, thing or like industry, so they have a very high level of they need a very high level of programmers in their IT team. So also, so it's because they have to make a very strong profile in this digital world. Okay, so coding is like one of the most skills right now. To understand and use technology better, you need to learn code. Okay, so if you want to know how apps, AI, and machines work, so you need to have some coding knowledge or how to do programming and all these things. You can control your computers instead of just like using them, just like the Iron Menders in Marvel and what Jarvis is being trained for. And we can also become more technologically literate, like having some technological tech background or having some knowledge. So in it's a major edge in the 21st century. So we can't just being a user, and we can also be a creator. Okay, by learning coding and programming, we can also do this for fun and challenge and creativity, because like programming is also like solving puzzles with logic and math. So it's addictive and satisfying for some people, and for some it may be frustrating, but yeah, it's good enough to knowledge. Okay, we can make games, art, music, or some kind of simulations also through coding. And there is a very creative side for lighting elegant and very beautiful codes. Like it's like a Lego, but with infinite possibilities. You can do anything using your own computer, laptop, PC, and just do coding and write some programs, and you will solve some problems and create a solution out of that. Okay, so to change the world, like code actually powers medical devices, the new emerging Tesla self-driving cars, and BYD also, and climate simulations. Like we can predict the future climate conditions with machine learning, and spacecraft and satellites are actually controlled by coding. And the Recently, like NASA has actually updated their software on the Voyager 1, which is far far away, but it still uses the assembly as its language, which is like compiled directly into the binary which the computer of the Voyager 1 satellite understands. So that is the thing. And now it's AI for education, justice, or accessibilities. Like we can use and AI is a very emerging technology which is like dominating each and every field. So we can use code to solve real world real human problems. And to automate our life, what we can do is we can scrape the data, some data from the websites. We can auto generate reports and build some custom tools for like working, and we can also connect APIs which are kind of a backend for sending WhatsApp messages or Google Sheets and everything, while saving time and effort. And we just have to build it once and we can use it forever. Okay, so that's all. Why should we start with coding? Okay, so that is the thing. And right now you may also get a question that I have used two terms, coding and programming. So what is coding as programming? See, the term coding and programming are like used interchangeably, like I used before. So but words have have a differences in scope and depth. See, first I will explain you about coding and then I will go on the programming one. See, coding is like writing code. Coding is like act of writing some instructions in a programming language like Python, C, C++, Java, or any other programming language. And it's like we are just writing some code, and it actually focuses on translating logics into syntax. Like we are converting the logics into syntax. See, computer doesn't understands English or the code which we have written. It actually gets compiled or interpreted into the binaries, and then the computer understands it, and the logic, the code we have written is converted into the logic which can be understood by the computer. So then only the task or the process can be done properly. And coding is like mostly about writing the lines of code which you have seen in various like movies or something. And it typically comes after planning. After the planning is done, like we first have to plan something before executing in a code. So it's like that. And the coding can be like considered as implementation phase, like of a program or of a mathematical anything formula like that. For example, we have to print something up to 10 numbers. Okay, so that is like coding. That's like using loops or all those things. Then comes the programming. Programming is a full problem solving process. Programming is a broader process that includes understanding a problem. We first have to understand the problem, plan, then we have to plan the solution by making algorithms and flowcharts. Then we have to write the code, which is coding. It means the coding is a part of programming. Okay, then in programming, after writing the code, we have to test the code. If we have got some errors, so we have to debug it. Debugging means solving the issues which we have got. And after that we also have to maintain the updating versions, adding features and all those things into software, website, or anything. So we have to do all these things in programming. See, basically programming involves logic, design, analysis, and thinking for a complete solution for a problem. Okay, it includes coding. It includes coding as a sub part. It means coding is a part of programming, but programming is not a part of coding. Okay, a programmer can design software architecture, choosing the with choosing the right algorithms and handle edge cases. Choosing the right algorithms is the key feature for programming, because if we choose a wrong or a incorrect algorithm or some bad kind of data structure, then our software may be slow or may become worst even in cases, some cases. Okay. And example like we take for programming is creating a web application, then that connects a database, handles user input, manages errors and scales. That is programming. Okay. So that is the thing. Then what you were thinking, like we have done with programming, right? So now what is hardware processing? Like we have written the code. Okay. So how does hardware, like what is the hardware processes it? What are those things? Okay. Okay. So a process is, see, let's start with processes. Okay. So a process is is an instance of a program in execution. Like we schedule a task or trying to execute a task uh, of a program. So it is a process. Example: if we open Chrome 3 times, each window is a separate process of the same program but with a different instances. Okay. You may have understood, like here I have opened a Chrome instance with only one, but you may see that there are multiple, but you can only see one. Okay. So how processes work? Okay. So first we have to run a program. Example for opening some programs from the task manager. If you are using Windows, so you have to double click on it, or use a command line if you are using Linux. So we have to first run a program, then the operating system actually loads the program code from storage into RAM. Actually all of the software's code, which is like bin files for Linux, or some like what is in the Windows, which extension is in the Windows.exe, which are actually stored in into the hard drive or the solid state drive SSDs. Okay. So these are actually stored in the part of a storage hardware. Okay. So but while we have to run some a program, like here I am running Chrome. Okay. So Chrome is actually stored in the operating system hard storage. Okay. But while we have open it, it actually gets loaded into the RAM is like random access memory, which actually runs which actually compiles and does all these processes in real time. Okay. So this operating system actually creates a process, assigns some memory to it, and a CPU time, and a unique ID, which is also known as process ID. For my Linux, if I go to system monitor and then we may go to processes, so you can see here Chrome has some CPU is using some percent of CPU, is using some percent of is using ID. Okay. So here not percent, it is a different random ID which is allocated to this Chrome's renderer. Some 27 megabits of RAM and all these things are allocated. Okay. So this is how all these things work, and after that a CPU starts executing instructions from the process. Now suppose Chrome has told me while opening after opening Chrome, it has been programmed to load the first page. It has been loaded the first page. Okay. क्या okay, okay. So you may like push the volume. I think so it's because of that. Sorry for, like, you may push the volume. So okay. The okay, so we were on CPU. So actually starts executing the instructions from the process. Like if we have open a Chrome, so it will tell the CPU to load the login or the some kind of this starter page of the Google search engine or all those things here, which will be told by the which will be written in the program and will be executed by the CPU. Okay, so now the operating system keeps switching between processes rapidly, and this is called context switching. And when a process is done, the operating system cleans up the memory and all those resources. Okay, so now what we have seen what is being done by the hardware. Now what happens in the no what is being done in this software part. Okay, so now what happens in the hardware. So first of all, the instruction is being fetched. Now what does it mean? The CPU actually fetches the next instruction from the process code in the RAM using the process program counter, which is also known as PC. Then the instruction is decoded. Now the CPU decodes the instruction using its control unit or like arithmetic logic unit. So that, for example, add register A and B or load from memory address X. Such kind of control units are there in CPU. Now execution is being done. The CPU executes using arithmetic logic unit or any other circuits. Okay, it might perform calculations, access memories, or interact with its hardware. Now memory access it requires memory access if needed. So if instruction needs data, the memory management unit MMU for the CPU, which translates the virtual address to a physical memory address, and after that it reads and writes data from and to RAM or cache. So it's all those things which is done by the CPU and RAM. Now after writing back, the result is written back to the CPU registers or memory. This loop repeats billions of times per second, and that's why there is a problem of heating and all those issues which needs to be cooled down properly, the CPU and all those comes. And this is how operating system and hardware, all these things interact with CPU, RAM, registers, cache, disk, MMU, OS, kernel, and scheduler. So now I will tell you what these terms mean. Okay, so or what are the roles, right? So CPU, which executes instructions of the process, RAM, which actually holds the process code and data, registers actually working data, like they are very fast and are very temporary also. Cache actually speeds up access to frequent instructions or data. Then in disk, where all the process code is stored like originally. And after that, MMU, which is just a second, which is like memory management unit, which actually translates the virtual memory to physical memory. And the OS kernel, which manages scheduling resources, memory, and input output of all the programs. And scheduler actually decides which progress runs on a CPU and when it needs to be run on a CPU. Now there are multiprocessing and multi-threading uh, concepts also in modern CPUs. Okay, the modern CPUs have like multiple cores. Like my CPU have 4 cores, so it can run multiple processes simultaneously. Okay, each process may have multiple threads. Uh, Threads means smaller units of work inside a process. So my CPU has 4 cores and 4 threads. So it it can divide like 4 process or eight I think so 8 processes at a single time, or like a simple addition. Now operating system uses context switching to make it appear that even more processes are running than CPU. So if I go to system monitor, and while I look into the resources, you can see that there are 4 CPUs. Then I have a RAM of 16 GB, and cached RAM is 6 GB. And then there is my network and disk here. So you can see all those data here. So right now my CPU is overall like average is 70, around 60-70%. And here you can see all those 4 cores which are running this CPU, and they are all equal. Okay, So it's like that. And all these things are like multi-processing and multi-threading. And CPU is kind of a chef, you like in a restaurant, which does all those tasks in the back end. And each process is also isolated, so every process runs its own protected memory space too. Okay, each process is isolated. So if we see at a process which is running in the back end of a CPU or the computer or a PC, it is like protected using its memory space. One process cannot access another's memory unless it is being allowed. So this ensures security and stability among different kinds of processes which are running concurrently. Okay, so here we have seen the operating system and interactions with its hardware and all those things. So let's get with kernels and drivers. Right now I have used a word named operating system kernels, and there is a one more word named drivers. So both of these are actually very much important in terms of computer science. Okay, see, kernels and drivers are two major parts of how operating systems interact with our hardware. Okay, but they serve some different kinds of purposes, and let me break it down. Okay, so let's start with kernels. The kernel is the core of the operating system. It acts as bridge between software and the hardware. So it means kernel is a kind of code or functions or programs which is the core of operating system, like the Linux kernel. Okay, Linux is a kernel, and then Ubuntu is an operating system. So Linux is being the base of the Ubuntu operating system. So we may call it Linux or Linux kernel, which is acting as core for the operating system. It what it does, it actually bridges the gap between softwares and the hardware, like how we tweak the software and how all this logic performs with the hardware and with the CPU at the back end. So kernels are those things. It's actually the central part of operating systems, like what I have told you, like Linux. And in Windows there is Windows NT kernel, only N and T kernel. And in Mac also there will be like Unix or kind of that. So that is the thing. And after all, it the kernels actually manages memory, CPU, process scheduling, and input output for all processes and tasks which are scheduled. The kernels also handle some system calls which are made by the application. So there may be some system changes which may require for some softwares which are being written, which is being tweaked by the kernel, and can be handled by the CPU through circuits or ALUs and all those things. See, kernel is a hardware agnostic, like it doesn't directly know how to talk to each specific device. Okay, it doesn't directly know how to talk to each specific device, but decide when a process should run, how memory is allocated, and routes input output request to the appropriate driver and all those things. Now driver, okay, I have used the word driver. So driver is a program that tells the operating system how to communicate with a specific hardware like GPU. There there are some drivers. In Windows we need to install drivers for printers and all this, like there are different drivers for to communicate with different hardware, uh, pro with different hardwares, like speakers or mic and everything, which may be sometimes fully we get them installed, or sometimes we need to install them. Or for Bluetooth, Wi-Fi and everything, sometimes we have to install, and sometimes it is already installed into a system. Okay, so what does a drivers do? Drivers are like specific to particular device, example printers or GPU drivers are like main. And for keyboard also, keyboard drivers are basic, and they are pre-installed in each and every operating systems and kernels. Okay, so they work under the kernels usually and are also loaded by the kernel to interact with the hardware. So basically kernel does all this task for processing, managing input output and all those things, and then the kernel uses the driver to interact with the hardware. Okay, so also the driver translates the generic operating system request into device specific commands, like what a person does with Arduino or some keyboard or keys. Like if we type C, so it should type C in the code, also in the everything other things and graphics. Like if we are doing such some fix graphically heavy, so we need to shift from CPU to the GPU. So all these things are tweaked by the kernel, but they are actually being done by the drivers. Okay, the kernel tweaks the processes and the driver performs the processes. Now we have seen kernels and drivers. Okay, so after that we now I will tell you why to start with C. See, it's a, I know it's theory and also it's modern. So many people will say, well, like why should we do C? Why we need to study C? Okay, but C is the most basic programming language after assembly that we can write to interact with drivers kernels. So by using C, you know what, we can study JavaScript. I know JavaScript and I know many different programming languages also, but with C what we can do is we can make a database, we can make a very rare kind of projects like what today's generation are missing, like making databases or some softwares, like what tweaking with hardwares. Okay, but what is the scene at the back end when you will use Arduino or any other different kind of uh, projects or do in school or colleges. So you need to have some knowledge of C, because you should know C, and the main reason behind it is you have to work with the hardware. So let me tell you in uh, let me expand this for you. Okay, C programming language actually teaches us how computers actually work. C is very close to hardware. The kernel for Linux and many other operating systems and the drivers and all these things are like written in C. So C is very close to hardware, and unlike high level programming languages like Python or JavaScript, with C what we can learn is how memory is allocated. We see, now I'm listing some things which we can't do in Python or JavaScript. In C we can see how memory is allocated and managed for a program, how we can do this and how what are pointers. Okay, what pointers are and like why they matter, and how the CPU talks to the RAM and peripherals, why data structures like arrays and linked lists really work under the hood. Okay, so C gives us all this control over over the hardware, so we can be the owner of the co- computer or the program which we are writing. Or C gives us a mental model of what's really happening inside the computer, so we can have a complete knowledge of that. And also like C is very big foundation for most of the systems. Like I have already told you, let's C is the mother of modern computing. Operating systems like Linux, Windows, Mac OS are already written in C. Many embedded systems like and firmware and microcontrollers are also using C. The Python interpreter itself is written in the C, which is called as C Python. It means the Python which is interpreted is at the back end is compiled. It's not compiled, it's actually interpreted in C language, but because of its line to line interpretation, it actually gets slower and slower. I will tell you, it's we will study all these things in further classes. We have to first understand the theoretical part. Okay, so if we want to build our own operating system, robots or compilers, so C can be the best programming language still. Okay, so the third reason for starting with C may be for zero magic. I will title it as zero magic because high level programming languages hide complexity, which may be good for speed, like completing some task very much fast, smooth, but it is bad for understanding. Okay, so in C, we have to manually allocate and free the memory or what for about the RAM. Then we have to deal with data types very strictly. Okay, we have to deal with data types. If we fail to do so, then our program might get failed or slow. Okay, so also in C we actually write everything ourselves, so we don't have to like rely on other programming languages compilation and all those things. So we can do all these things with ourselves only, and also we can learn why things work the way they do. So there is no there is no garbage collection, no magic syntax, just raw computing. Okay, then efficiency and speed also matters. With C is one of the most fastest languages out there, so which directly compiles to the machine code. So so we can write performance critical code used in operating system kernels, game engines and databases. So like yeah, we can make game engines and databases and operating system, which I've already told earlier, but game engines is an addition to it. Like what is a game engine? Game engines like example Unity and yeah, Unity, and I can remind the second one. Okay, so C is like the most performant. C is for when C can be used when the performance actually matters. So now my fifth point to why to start with C may be like which is a solid base for other languages. Okay, so when it comes to C++ actually value becomes very easy because it's just C with object oriented features. Okay, and you will also understand why Python, Java and Rust are what are they like doing internally, how they work under the hood at the back end. Then you will also be better at debugging, optimization and writing clean code, which is one of the most important thing in computer science, that we have to write clean code, and optimization is the most common technique which we should know how to optimize our application. Okay, and mastering, we have to master C because every other languages, then after that every other languages are easier for us to learn. Like if we start with the hard ones, so the easy ones become more easier. Okay, so also my sixth point maybe which is good for why to start with C is good for embedded and hardware projects like Arduino, Raspberry Pi, GPIO and microcontrollers, firmwares or BIOS and all those things. BIOS is like which actually loads the boot kernel and configures every kind of hardware from the very scratch before the operating system into our computers, and they all rely on C. It's not a question. They all rely on C. So we should start with C. Okay, and not only with C, we can also start with other programming languages also. But let's talk about first like other programming languages. What if we start with other programming languages? So starting with another programming language like Python, JavaScript or another kind of Java, so it's good. So, but like depends on your goals, your choices. Okay, so let's first explore like why we should start with languages, why we should like explore the languages, other different languages that are other than like C, or it's a good or it's a bad idea. So Let's get started. Okay, so if we start with high level languages, example Python, JavaScript, so there are some advantages like we can fast learn fast, we can learn fast, and we can use it fast. Okay, but we don't have to worry about memory pointers or manual setup. We can print hello world in one line and we can get quick feedback, great for motivation. Okay, but also like most of the things like we can have a very quick success. Okay, but it's an immediate creativity also, like for building websites using JavaScript and automate tasks using Python and make some games by game. So yeah, it's good. It's perfect for like beginners who want to see results very fast. And there are real world uses also, like Python is uh, used widely in the AI, data science, web development, and automation. JavaScript powers almost every single website on the web, and great. It's great if you are aiming for jobs or doing some projects quickly. But the disadvantages are like abstraction, which hides the machine. Okay, abstraction hides the machine. Python handles memory, garbage collection, etc. behind the scenes. But if we have to understand, we have to go with C. We can't learn how things work under the hood until a weaker foundation. At first, we don't need weaker foundations like okay. So like if you don't understand what is C or like how the things work, so it's not a good thing. Like we will have a like weaker foundation if you only use high level tools. If you might struggle when you hit performance, embedded system, or hardware level some problems, so you may fail there. Okay. Then you may have some bad habits like lack of discipline. Example, ignoring memory usage or data structures can lead to like sloppy coding. You can't just do chat gpt every single time, like why it's memory uh why it's like memory usage error is coming, or it may be because of the data structure, but you can't understand because all these things are compiled or integrated under the hood by the C only. So C is the father and mother of every programming language and every embedded system, every operating system, every kernels, drivers, and all these things. All are written in C. You can't change it. Okay. Then you might rely too much on trials and errors instead of logical thinking, right? You can go to ChatGPT, write code, and it's not good. You need to have some logical thinking. Why I'm getting this, why I'm getting this error, like getting these warnings, all those things. So you need to have knowledge about that. Okay. So what's my ideal approach is like you must start with C if you want to understand hardware deeply. If you want to build websites fast, you can make embedded systems and do robotics, then you can go with us C or C++. And if you want to go for some general purpose programming, you can go with Python. See, I will cover up all in live stream, but before going to higher programming languages, we must start with some great scratch programming languages like C. So yeah, I will teach everything in just live sessions, so you don't have to worry. Like I will only go with C and not with others, so I will teach all these things. Okay, now let's understand what is the role of each programming languages. So right now which is created in the 1970s to build operating system, and like it directly converts its code into the machine code, which can be directly understood by the machines, and it is used in Linux operating system kernels, embedded systems, drivers, compilers, and all those things. Now C++ is like C with object oriented programming features, OOP features, which is made for some large applications like game engines, high performance apps, And system tools like tweaking some hardwares, like changing the brightness of the screen and all those things. Now Python is actually very simple and readable syntax for rapid development, and it is like best used for AI ML data science and automation, web applications and scripting. Now Java is like write once, run anywhere via the Java virtual machine. Okay, it's a kind of it makes such virtual machine kind of thing, and it is used in Android applications, enterprise systems and backend web development using the GSP. And JavaScript is like originally for dynamic web pages, like front end. We can build front end using React, back end using Node.js, and complete web applications also. Now Go, or Go language, is created by Google for concurrency and simplicity. It concurrently and like simplicity. Go languages is used mostly in cloud computing, microservices and networking tools. Okay, now Rust is safe systems programming with C++ performance, but I will not recommend you to learn Rust at the very starting point, because you may get demoralized and demotivated very fast. So Rust is like safe systems programming with C++ performance, and Rust is like used in operating systems right now. The newer operating systems are like written in the Rust, and they are like changing very quickly also. And Rust is also used in security critical systems and web servers. Now, our next programming language will be Ruby, which is designed for developer happiness and elegance. Web app used in web apps, especially with Ruby on Rails. And just a second. Yeah, and uh, designed for developers, like web applications with Ruby on Rails. PHP is kind of made of for server-side scripting for web development, and web backend WordPress, and it is used in web backend, like WordPress, which actually powers most of the website next to JavaScript. And Laravel is kind of framework for PHP's front end, and we can do this. And after that, like, we have Swift, which is Apple's modern language for safety and speed, and it is built for iOS and macOS applications. So Swift is kind of their ecosystem programming language. Then Kotlin is kind of made for modern web replacement for Java on Android. Like Kotlin can be written 40% less code instead of Java. So, and it is like built only for Android apps. Then we have R language, which is designed for statistics and data visualization, is used in data science and statistics, and one more field, bioinformatics. Then we have TypeScript, which is an extension for JavaScript, which actually which is an addition with types for large projects. We can have some scale. We can make some scalable web applications with strict typing in Angular or kinda Next.js. Then we have SQL language to construct to create, which is created to manage structured databases. Using SQL, there are some commands which is used for querying and managing relational databases, RDBs, for MySQL, Postgres, and Sqlits. Then there is MATLAB, numerical computing, which is used for numerical computing and simulations. And there are many programming languages, like, and yeah, Bash, or the shell, is one of the most important command line interface, or CLI, or the terminal, which we use in Linux. Zesh or Fish, all these things are terminal languages. Okay, and Scala and all these things. There are many languages for like if we categorize them for usage for AI and data science, we can use Python, R, Julia, and MATLAB. For web development, we can use or you can go with JavaScript, TypeScript, and for both front end and back end, Django and Flask, which is in Python for back end, and Django for front end, Flask which is only for the back end, then PHP, then Ruby on Rails, and Go language for web development. If you go for mobile application development, then Swift is only application for iOS, and Kotlin, which is kind of for Android. We can also use in Dart language, which is written by the which is like made by the Google, uses the in the Flutter, so which is a cross platform application. We can make Android and iOS application at once, and not only Android and iOS, we can make watch applications and many different kinds of application for using Dart language used in Flutter framework. Then we have Java, which is a legacy Android application developer. Okay, and then if you have to make some system and hardware level programming, we can go with C, C++, Rust, and assembly. For enterprise and backend, Java, C Sharp, Go, and Python is the best. And for scientific and mathematical computing, we should go with MATLAB, R, and in Python there is some kind of libraries like SciPy and NumPy, numerical Python, and Julia is another language for mathematical computing. Okay, so all these things, like I have told you, like role of each and every programming language. Now, okay, wait a second. Now, if we go to like I have also told you like which is the perfect language. So I have already told you. So you may all do all these things. So okay, so I will also make you some short guidance if for a few fields. Okay, if you want to go with AIML data science, so first start with Python and then do R or Julia, and learn math, math and machine learning libraries. Then for web development, for front end, learn HTML and CSS. Then do JavaScript, and after that you can go with React or Vue.js. And for React, there is a React compiler right now, and if you don't want to use React compiler, so you can go with Vite, which can compile the front end. And for the back end, you can go with Python, which is for Python there are two libraries, Flask, Django. Right now there is one more, which is Fast API, which can make the back. Or for JavaScript also you can do Node.js and what is that, Express.js. You can do some SQL for a back end database for all these things. And after that also there is for robotics and IoT, you should go with C. Then you have to learn micro Python, Arduino software development kit, Arduino SDK, and then ROS and Python. For you, if you have to make operating systems or like some system engineering, so you can start with C, then go with C++, and after that you can go to Rust and assembly is the most basic, and I will not recommend you to do assembly because it is the worst programming language. Not the worst, it is the best programming languages, but to learn it may be worst, so you can start with C. Okay, so next is like for mobile application development, you can start with Android, do Kotlin, do Jetpack. For iOS you can go with Swift or do the Swift UI packages and all those things. For cross platform, you can go with Dart language and the Flutter framework. So like there are different kind of programming languages, so with different kinds of needs. So that's all thing. And here we will end our stream, and I'm giving you advices and all those things. So study programming language which you want to on your like uses. Okay, so that's not the great thing. Let me go with the live chats of let me open the live chats. If you have some doubt, you can tell me. um okay, just wait a second. don't know what happened with the website of. Wait a second. Okay, it's because of the buffer, I think so. I think the network is slow for that reasons. It may be slow. Kinda, yes. Is my stream buffering? No. Okay. Um. Voice is not clear. Is it live? Yes, it's live. Okay, so I will end up this stream right now, and then let's meet in another